Good evening everyone, myself Saikmar. Now I am going to discuss about the embedded real-time systems seminar topic, which is case study audio player. Now coming to theory of operations and requirements. First let me discuss about what are the requirements and theory of operations required for the audio player. In this example, we will design of a portable MP3 player that decompresses the music file as it plays. Audio files are often called MP3 players after the popular audio data format, although the number of audio compression formats have been developed during regular use. Next, audio compression is a lossy process that relies on perceptual coding. The coding eliminates certain features of the audio stream so that the result can be encoded in fewer bits. Next, it tries to eliminate features that are not easily perceived by the human audio system. That means it is different from the human audio system. The term MP3 comes from the MPEG-1 layer 3. The MP3 spec is a part of MPEG-1 standard. So these are the standards MPEG-1, MPEG-3, and the layer 3 is the standard of the MPEG-1. The standard define three layers of auto compression: layer 1, layer 2, and layer 3. Coming to the layer 1 uses a lossless compression of subtracts and an optional simple masking model. Layer 2 uses a more advanced masking model. Layer 3 uses an additional passing to provide lower bit rates. Next coming to this block diagram, it consists of a filter bank, FFT, masking model, quantizer or encoder, scale factor, and multiplexer. That means input signal is converted into the video or audio format. Next, MPEG data streams are divided into the frames. The frame carries the basic MPEG data, error correction codes, and additional information. So the frame may have the data or may have the error or may have the additional information. Here the header format of the frame is given as header, cyclic CRC, that means cyclic redundancy check, and bit allocation and scale factors, and subband samples and data. Next, coming to this block diagram, it consists of a demultiplexer, which means it's converting into the signal. It consists of demultiplexer, which is transferred into the scale factor. Next, it is expanded. Next, it is transferred to the inverse filter bank. Next, it's transferred into the signal. Next, coming to the requirements, the file systems. The file systems of the player generally must be compatible with PCs. CD or MP3 players use compact disc that had been created on PCs. Next, coming to the requirements, name and audio player, purpose, play audio from files. Next, inputs, purpose, inputs, outputs, functions and performance, manufacturing cost, power, physical size and height. Let me discuss about each purpose. Play audio from files, flash memory socket, on or off, play stop menu, up or down. Next, outputs is a speaker. Next, functions, display list of files in flash memory, select file to play file. Performance, for any device the performance should be high, sufficient to play audio files at required rate. Manufacturing cost approximate $25. Power 1 AAA battery. Physical size approximate 1 x2 less than 2. Next, coming to the specifications. What are the specifications required for the audio filter? The figure shows the major classes in the audio player. The file ID class is an abstraction of a file in the flash file system. The controller class provides a method that operates the player. Next, coming to this, if we start, let we are initializing display is equal to 0. Send files on display dot names to display. We are sending the files. Next, we are clicking the button. The buttons are of down, up, and play. If there is a down button, wrapper round of I-1, wrapper round of I+, play files of display. Again, after completion of these files, again we need to play another song, so that we can click on the button, we can click up or down or play. If the file management is performed on a host device, then the basic operations to be specified are simple file display selection and playback. Figure shows a state diagram for a file display selection. This specification assumes that all the files are in the root directory and all the files are in the playable order. Next, coming to here, start. We need to open file, we need to read file, we need to parse frame, decode frame, sends a sample to the audio systems. If it is the last frame, to end, and if it is not the last frame, we need to read a continuous read frame, parse frame, decode frame, and send samples to the audio systems. Next, coming to the system architecture. The system architecture, next, it is of the address CS7410 for CD/MP3 players. The audio controller includes two processors. The 32-bit RISC processor is used to perform system control and audio decoding. The 16-bit DSP is used to perform audio effects such as equalization. The memory controller can be interfaced with several different types of memory. Flash memory can be used for data or code or storage. And the other memory used is DRAM. DRAM can be used as buffer to handle temporary disruptions of the CD data stream. The audio interface unit puts out audio in formats that can be used by AD converters. Next, the software architecture is relatively simple. The only major complication occurs from the requirements of the DMA or other method to overlap audio playback and file access. Next, in the specifications, we have the disk processor, CD interface, I/O. CD interface is connected to the CD device. DSP and memory control. Memory controller connected to flash, DRAM, and SRAM. Next, audio interface, SRAM and ROM. Next, system integration. The most challenging part of system integration is ensuring that the audio layers works or play smoothly without interruption. There should be no interruption. Any file access and audio output that operate concurrently should be separately tested, ideally using an easily recognizable test. The main thing for the system integration is the performance of the audio player should be higher. Simple test signals such as tones would more readily show problems such as delayed or missed samples. Thank you very much.